What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA A+ 1202 certification exam. So let's get into it. All right, so if you're studying for the CompTIA A+ 1202 exam, then you know that one of the most important skills that you need to master is how to install applications properly. Now, you might be thinking, installing applications, that sounds easy. You just click next, 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 and finish, right? Well, not exactly. In IT support, installing applications isn't just about clicking a button. It's about making sure the computer can handle the application, ensuring compatibility with the operating system, verifying that the network can support it, and understanding the impact on business operations. That's why in this video, we're going to spend some time walking through every angle of installing applications. And by the end of this video, you're going to know how to check system requirements before installing an application, the different distribution methods, and the impact considerations when rolling out new applications in a business environment. So with that being said, let's go. All right, so when someone asks you to install software, whether it's a new payroll system at work or a simple PDF reader, your first thought shouldn't be, where's the download link? Instead, your first thought should be, can this computer even run the software? That's what we mean by system requirements, because every piece of software comes with a list of minimum and recommended requirements. And as a tech support professional, it is your job to check before you install. Otherwise, you risk crashing the system, slowing down performance, or leaving the user frustrated. So let's break down the different types of system requirements that you need to know for the exam. The first one is 32-bit versus 64-bit dependent applications. So one of the most common compatibility issues that you're going to face is the difference between 32-bit and 64-bit applications. So when it comes to 32-bit applications, they can run on both 32-bit and 64-bit operating systems. They are limited to 4 gigabytes of RAM maximum. And even if the system has 16 gigabytes of RAM, a 32-bit application cannot use at all. And many older applications are 32-bit, but modern operating systems are phasing them out. So for example, Windows 11, it only supports 64-bit CPUs. And then we have 64-bit applications, and these require a 64-bit CPU and operating system, and they will not run on a 32-bit system. And a 64-bit system, it can handle more memory, which is critical for demanding applications like video editors, CAD tools, and modern games. And they just overall offer better performance and security in most cases. So let's say that you're working in IT support for an accounting firm, and one of your accountants wants to install a new version of QuickBooks that requires a 64-bit operating system. Now you check their PC and you realize they're still running a 32-bit version of Windows 10. In this case, the application will not even install. So your recommendation will be to back up their files and upgrade them to Windows 11 64-bit before installing the new software. All right, next we have dedicated versus integrated graphics cards. So not every application needs a graphics card, but for those that do, it makes all the difference. So when it comes to an integrated graphics card, basically they are built into the CPU and they are great for web browsing, office applications, streaming video, and light photo editing. But they have limited performance for 3D rendering, CAD, or high-end gaming. And then you have what is called a dedicated GPU or a graphics card. And this is a separate piece of hardware that is optimized for processing visuals and is needed for applications like AutoCAD, Adobe Premiere Pro, Blender, SolidWorks, Unity, or high-end PC games. And it comes with its own VRAM, which takes the load off the system's main memory. So a real-world scenario where you would use this is your company's design team, they want to start using Blender for 3D modeling. You check the hardware and realize most of the laptops only have integrated Intel UHD graphics, and then you realize that that's not going to cut it for rendering complex 3D models. So then you recommend upgrading the laptops with at least an NVIDIA RTX 3060 GPU. Next, we have VRAM requirements, and VRAM, that stands for video RAM. And so when it comes to video RAM, you got 2 gigabytes VRAM, and this is fine for basic video playback and light photo editing. You got 4 to 6 gigabytes of VRAM, and this is suitable for 1080p gaming, moderate video editing, and some CAD work. And then you got 8 plus gigabytes of VRAM, and this is needed for 4K video editing, 3D modeling, CAD, VR, and AI machine learning workloads. Now, as an exam tip, if an application requires 4 gigabytes of VRAM, a system with only integrated graphics, which typically shares system RAM and has 1 to 2 gigabytes max, this will not meet the requirements. That's essentially a red flag that you should watch out for. Next, we have the RAM requirement. So you got 4 GB of RAM, and that is a minimum for basic office applications like Word, Excel, and web browsing. 8 GB. This is comfortable for most users, light gaming, video calls, and multitasking. 16 GB. This is recommended for graphic design, video editing, virtualization, and modern gaming. Then you got 32 GB plus. This is needed for heavy workloads like running multiple VMs, databases, or high-end content creation. Now, as a real world scenario, let's just imagine that you're helping a student install VMware Workstation Player on their laptop and they want to run both Windows 10 and Ubuntu simultaneously. You check their system and see that they only have 8 GB of RAM. Since each VM might require at least 4 GB for the host operating system, you need to recommend upgrading to at least 16 GB of RAM. Next, we have our CPU requirements. So the CPU, this is the engine that drives everything. And some applications are light, while others demand serious horsepower. So we have our entry-level CPUs like Intel Celeron and AMD Athlon, and this is fine for email, browsing, and light applications. You got your quad-core CPUs like the Intel i5 or AMD Ryzen 5. This can handle multitasking, light editing, and most business applications. You have your high-end CPUs like Intel i7 and i9, the AMD Ryzen 7 and 9, and a Threadripper. And this is needed for CAD, virtual machines, databases, video rendering, and AI workloads. Now, as an exam tip, if an application requires an x64 architecture, then just realize that you cannot install it on a 32-bit CPU. All right, so moving on, we have external hardware tokens. So some software requires physical external devices for security or licensing. First one we have is called a USB dongle license. And basically, this is used for high-end professional software like MATLAB or AutoCAD or music production suites that may require a dongle. You got smart cards and readers where they're used in government, healthcare, and enterprise for multi-factor authentication. You got hardware security modules, which is what you're looking at on your screen right here. And these are for creating encryption keys. They have biometric devices like fingerprint readers, facial recognition hardware, etc. Now, as a real world scenario, just imagine that an attorney's office, they buy specialized legal case management software. You go there to install it, but it will not launch. And after troubleshooting, you discover that it needs a USB dongle license key that the vendor ships separately. So once you get that, then guess what? Your problem will be solved. And then we have storage requirements. So applications, they don't just take up space when installed. They continue to consume disk space after people start using them. So we have installation files, and some of these apps, they can be huge, like the Adobe Creative Suite, which can take up 20 to 30 gigabytes of space. You got temporary files like video editing or CAD, which stands for computer-aided design applications that can create tens or hundreds of gigabytes in cache. You have free space requirements, where most applications recommend having at least 10 to 20% free space on a drive for best performance. You have SSD versus HDD. So SSDs, they launch applications faster and they reduce load times, which matters for big applications. Now, as a real world scenario, just imagine that there's a small business that wants to install QuickBooks on their office manager's laptop, but the laptop only has 32 gigabytes of eMMC storage, which is already half full. Now, you explain that the QuickBooks might install, but the updates and backups could quickly fill up the drive. So what is the solution? Well, you're going to upgrade to a larger SSD. All right, next we have application to operating system compatibility. So not every application runs on every system, so you have to check compatibility first. So you got Windows versus Mac versus Linux. So some applications, they only support one operating system, like Final Cut Pro, that only runs on Mac OS. You got mobile applications, where some applications are iOS only and some only run on Android. You got version compatibility. So a Windows XP era program, this might not work on Windows 11 without compatibility mode or a VM. And then you have driver and library dependencies, where Linux applications, they often require specific libraries or kernels to run. And as a real world scenario, just imagine that a user buys a tax software disk from 2010 and tries to install it on their brand new Windows 11 computer. The installation is going to fail because the application is not compatible with the modern operating system versions. So what you're going to do, you're going to suggest running it in a Windows 7 VM or using a newer version of the software. All right, so let's move on and talk about distribution methods for applications. So once you confirm the system meets requirements, then you need to figure out how to deliver and install the application. So here are the most common distribution methods that you'll see in IT support. We have physical media versus mountable ISO files. So physical media are things like CDs, DVDs, and USBs, and these are common in older software installations. However, they may still be used in offline environments like factories, hospitals, or secure labs. Now, the downsides are they have slower installations, there's a risk of a damaged disk, and fewer modern laptops even have optical drives to begin with. Then you have your ISO files or your disk images, and these are a single file that represents an entire CD or DVD, and they can be mounted virtually in Windows, Linux, or Mac, and they're much faster and easier than shipping physical disks. So as a real-world scenario, you would need to install Windows Server 2019 on a new server. And instead of using DVDs, you will mount an ISO file directly in the server management console and start the installation remotely. Then there's downloadable packages, and you have exe and MSI files, which are in Windows, and these are used for most desktop applications. You got DMG, PKG files, which are used for Mac, and these are drag and drop or installer packages. You got DEV and RPM packages, which are used in Linux, and these are installed via package managers like apt, yum, or DNF. Then you got app stores like Microsoft Store, Apple App Store, or Google Play. Now, as a security reminder, you always want to download software from official sources. Downloading cracked software from shady websites, this can introduce malware, keyloggers, or crypto miners into your system. And then there's the image deployment. So when working in IT support for businesses, you'll often need to install the same apps on dozens or even hundreds of devices. And that's where image deployment comes in. So we have what is called a disk image. And this is where you create what is called a golden image of a system that already has Windows, drivers, security tools, and company applications installed. You have various deployment tools like the Microsoft Deployment Toolkit, Windows Autopilot, SCCM, or the Microsoft Configuration Manager, and Clonezilla. And basically, this stuff saves you time, effort, and ensures consistency across all computers. So how would you apply this in the real world? Well, let's just say that you've been tasked with setting up 150 new desktops in a call center. So instead of installing Windows and the voice over IP software one by one, you would create a master image with everything pre-installed, and then using MDT or Microsoft Deployment Toolkit, you will push that image to every computer over the network. And what would have taken you weeks to probably do will now only take you hours to complete. All right, so let's talk about the impact considerations for new applications. So before you hit that install button, you need to think about the bigger picture. Installing an application doesn't just affect the device. It can affect the network, the users, and the business itself. So let's talk about some of the 4 big impact areas. The first one is device impact. So we have performance issues. So if the application needs more RAM, CPU, or GPU than the device can provide, then the system may slow down or even crash. We have battery impact. So on laptops and tablets, resource-heavy applications like Zoom, games, or video editing tools, they can drain your battery life. You got storage space. So installing large applications, this may cause low disk space, which can slow down the system. And then you have peripheral requirements. So some applications that require webcams, microphones, VR headsets, or printers. So as an example, an employee, they want to use Photoshop on their 8-year-old laptop with 4 gigabytes of RAM and no GPU. The application will install, but it will crash often and run extremely slow. So the best solution will be to upgrade the hardware or recommend a lighter photo editing application. And then there's the network impact, and within that you have bandwidth usage. So cloud apps like Zoom, Teams, and OneDrive, they can overwhelm bandwidth. You got update downloads. So applications like Windows, Office, and games, they often require large updates that can eat up your bandwidth. You got network security issues where some applications may open ports or bypass firewalls. And you also have remote work challenges where VPN-based applications that may slow down if too many users are connected at once. So an example of this would be a school rolls out Google Drive syncing to every student laptop. Then suddenly the network slows down because hundreds of students are syncing large video projects at once. Now, as an IT pro, you may need to go in there and set up bandwidth throttling or scheduled syncs. Another impact consideration is operational impact, and within that we have training. So users, they may need time to learn new applications because without training, productivity can drop. You have software conflicts, so installing 2 antivirus programs, this can cause issues. You have downtime, so installing applications across hundreds of systems, this can cause temporary interruptions. There's also licensing and costs because some applications require monthly subscriptions, which can affect the company budget. So an example would be be a business switches from Dropbox to OneDrive, and employees, they will initially struggle with the new interface and lose productivity until proper training is provided. And then we have the business impact. So installing new applications, this can have a major effect on the entire organization, such as compliance risk. For applications used in healthcare, they need to be HIPAA compliant, and finance applications that need to follow PCI DSS. There's the issue of cost management, because subscription-based applications can get expensive if they're not monitored. You have productivity impacts, where a new application can boost efficiency or can slow everyone down if not implemented properly. Then there's security concerns. So installing unauthorized applications, this can introduce malware or violate company policies. So an example of this would be a company installs a free file sharing application without approval. Then later, sensitive customer data leaks online because the application wasn't secure, and this could result in a data breach and potential legal consequences for the company. All right, so let's bring all of this wonderful information together. So let's put this into a story so you can see how this works in real life. So let's say that you're working as an IT support specialist at a mid-sized company, and one morning you get a ticket that says, please install Adobe Photoshop and Microsoft Teams on my laptop. Now, this sounds simple, but here's how you would approach this as a professional. First thing you're going to do, you're going to check the system requirements. So Photoshop, this requires 8 gigabytes of RAM, a 64-bit Windows system, and at least 4 gigabytes of VRAM. And Teams, this requires Windows 11 and at least 4 gigabytes of RAM. Next, you're going to check the laptop specs. So the laptop has 4 gigabytes of RAM, a 64 gigabyte SSD, and integrated graphics. And then you're going to realize that that's not enough RAM or VRAM to support Photoshop. Then you're going to assess the impact consideration. So if you install Photoshop anyway, then your laptop is going to crawl. So the user might experience constant freezing, which will hurt productivity. After all of that, you're going to recommend upgrades if needed. So you're going to explain to the user that Photoshop will install, but with only 4 gigabytes of RAM and no dedicated graphics card, it's going to run really slow, or it might even crash. So you're going to recommend upgrading the laptop with at least 8 gigabytes of RAM, or suggesting a desktop with a dedicated GPU if they'll be doing heavy design work. And this shows that you're not just a quote unquote button clicker, but you're going to be a trusted advisor who helps the business make smart technology decisions. And then you're going to choose the right distribution method. So you're going to grab Microsoft Teams from the official Microsoft website. For Photoshop, you're going to install it via the Adobe Creative Cloud desktop application, which manages license and updates. And then you're going to test everything. So you're going to launch Teams to confirm that people can log in. You're going to launch Photoshop by testing it with opening up a sample file. And then you're going to check system performance. So if the laptop lags, you're going to note it in the ticket and recommend the hardware upgrades. And guess what? After you do all of that, you've not only installed the applications, but you ensured system compatibility, verified performance, and considered business impact. And guess what? Everybody's going to give you a hug and a pat on the back, and you are going to be the hero. Now, let's quickly talk about some common mistakes that you need to avoid. So when it comes to application installation, here are some of the pitfalls that you got to watch out for. So skipping the system requirements check, this can lead to failed installs or unusable applications. Installing from unverified sources, this can introduce malware. Ignoring updates, this can cause outdated applications to become security risks. Avoid overloading devices, and you do this by not installing heavy applications on hardware that cannot handle them. Also, you want to check your licensing so that you can remain in compliance and avoid any legal issues for your business. And you also want to train the people using this stuff, because users are going to blame the IT people when they cannot figure out how to use a new application. So you want to train these people to avoid that headache as well. So how does all of this apply in the real world? Well, the truth is, application installation, this is one of the most common tasks for IT support specialists. So whether you're at the help desk, working as a desktop support technician, or supporting a team of remote workers, you're going to be asked to install applications all the time. But here's the catch. The exam and the real world does not care about you just clicking install. They care about whether you can check compatibility before wasting time. Pick the best installation method for the environment. Think about performance, network load, and business impact. And secure the installation by using safe sources and supporting hardware tokens. And when you understand this, you will go from being just the person who installs applications to being the IT professional who keeps the business running smoothly. All right, so with all that being said, let's go ahead and do some check on learning. So our first question is, a user wants to install a 64-bit database application, but the installation fails. The computer has a dual-core CPU, 4 gigabytes of RAM, and Windows 10 32-bit installed. What is the most likely reason for the failure? Is it the computer does not have enough RAM? The computer has a dual-core CPU? The computer is running a 32-bit operating system, or the computer does not have a dedicated graphics card? And the correct answer is the computer is running a 32-bit operating system. So a 64-bit application requires a 64-bit operating system and CPU. Even if the hardware has enough RAM and a capable CPU, a 32-bit OS cannot run 64-bit applications. RAM and graphics cards do matter, but they aren't the cause in this scenario. Next question. An architect is installing CAD software that requires a dedicated GPU with at least 6 gigabytes of VRAM. The installation completes, but the software crashes when rendering complex designs. Which hardware limitation is most likely the cause? Is it the computer only has 8 gigabytes of system RAM? Is it the computer is using integrated graphics? Is it the CPU does not support virtualization? Or is it the storage drive is a traditional HDD instead of an SSD? And the correct answer is the computer is using integrated graphics. So CAD and 3D rendering applications, they need a dedicated GPU with enough VRAM. If the system only has integrated graphics, it will fail to handle the processing load, leading to crashes or poor performance. While low RAM and HDDs can affect speed, they wouldn't directly cause the rendering crashes. And our final question is, a company wants to install Microsoft Office on 200 new employee laptops as quickly and consistently as possible. Which installation method should the IT team use? Should they install Office individually from a CD on each laptop? Have each user download and install Office themselves? Use image deployment with a pre-configured master image? Or use a bootable USB to install Office one by one? And of course, the correct answer is going to be use image deployment with a pre-configured master image. So in large scale environments, the most efficient way to install software is by creating a master image with all required applications and deploying it to multiple devices. This ensures consistency, saves time, and reduces error. Installing from CDs or USBs is far too slow for 200 laptops, and letting users install software themselves risks inconsistent configurations.